So voltage source and a conductor, if both of them connected in a closer circuit, then only current will flow. The answer is what? B. Next, sixth question. A fundamental law of electricity is that current flow in a circuit is, so direct so current is it directly proportional to the resistance. So option A, what is given, I, they are saying I directly proportional to resistance, it's wrong. And B, what is given, directly proportional to the voltage, I proportional to voltage, this is correct. More applied voltage, more current. Voltage is more means current is going to be more. So current in a circuit is directly proportional to the voltage, this is correct. What is a C, inversely proportional to the voltage, I proportional to 1 by V, they are saying this is wrong. And equal to the voltage, I equal to, it might not be, it might be equal or might not be equal, we don't know. Therefore what is the correct answer? Current in a circuit I is directly proportional to the V. This is a fundamental thing. So the correct answer is directly proportional to the voltage, answer is B. Next, seventh question. The ratio of voltage and current in a closed circuit is, see always, if the voltage changes means accordingly current is going to change. The ratio of voltage and current is always becomes what? Constant. So answer is A. Next, eighth question. It is about the charge Q. So charge Q flowing through a conductor, charge Q is given, and current is I, then t seconds. If the charge Q is flowing for t seconds, then it will result into current I. Then what is the charge Q flowing through the conductor carrying current I for a t seconds. So I current is flowing for t seconds, I is given and t is given. What is the charge value is asking. So we know basic current formula, I is equal to what? Q divided by t. So we want what is the value? Charge Q is equal to I into t. So what is the correct answer? A. What will be the unit of charge? It might be coulomb or it might be, current unit is nothing but what? Ampere, and time is nothing but what? Second. Ampere second is also correct unit. And let us see some previous year questions asked from these basic concepts. The value of total potential difference created between the two electrodes. Potential difference created between the two electrodes means like this. Usually we call this as a EMF, electromotive force. When the cell is not connected to an external source is known as electromotive force, electrostatic force, electromagnetic force, electromechanical force. This force is known as what? Electromotive force. Next, second previous year question. The measure of a coil's ability to produce a flux is called electromotive force, magnetic lines of force, magnetomotive force, magnetism. We all know EMF will cause the current in the circuit, in electric circuit. Similarly, magnetomotive force will cause the flux in the circuit. Magnetomotive force will cause the flux in the circuit. The answer is what? Magnetomotive force. Answer is C. And which one of the following represents a single element such as voltage source or resistor? So one is branch, node, loop, circuit. Which one of the following represents a single element such as voltage source or resistor? So the correct answer is what? Branch. Let us say this is a voltage source, and here we have connected one resistor, and here one more resistor is there. So this entire thing is called one branch, and this is also called as one branch. So element, so branch may contain single element or more than one element. Human body resistance is always about its 1 kilo ohm. conductance is a reciprocal of what? We know resistance R value which opposes a flow of current, and conductance means which allows the flow of electrons. Both have inverse relationship. So resistance is equal to 1 by conductance. So similarly, conductance is equal to 1 by resistance. So conductance is the reciprocal of what? Reciprocal of resistance. So answer is what? C. Next, about the resistance. So resistance of a conductor depends upon what? We know resistance of a conductor depends on length of the conductor. Resistance of a conductor depends on cross-sectional area of the conductor. Resistance of a conductor depends upon the type of material. So it also depends upon the resistivity. So what is the formula of resistance? R is equal to rho L by A. So resistance depends upon the cross sectional area, it depends upon the cross sectional area, it depends upon the resistivity, it depends upon the length. So the correct answer is what? All the above. So it depends upon length, cross sectional area and resistivity of the material. Next, about the specific resistance. The specific resistance is measured in, so we know R is equal to rho L by A. So this is a specific resistance. So rho is equal to what? RA by L. So this R rho is equal to specific resistance, rho is equal to RA by L. R resistance is ohm. Resistance units are nothing but what? Ohm. Cross sectional area units are meter square, and length units are nothing but what? Meter. So meter gets cancelled. So ohm meter. So resistivity units are nothing but what? Ohm meter. So ohm meter is the correct answer. A. Next, again about the resistance. The resistance of a conductor diameter D and length is R ohms. Length is R ohms. If the diameter of the conductor is halved and length is doubled, then resistance of the conductor. Let us say initially the resistance R1 value is R, and let us say length L1 is L before changing the dimensions, and let us say cross sectional area is A, and diameter of the material is D. But after the dimensions is changed, so the same material dimensions I am changing. So what happened? What dimensions are changed? Diameter D, what dimensions are changed? If the diameter of the conductor is halved, that means D2 is equal to D by 2. Diameter is becoming half and the length is doubled. So length is doubled means L2 is equal to, doubled means 2 times first length, that is 2 times length. And then what is the resistance of the conductor? So what is the R2 value we have to find? First of all, let us find the A2 value. So A2 value is equal to what? A2 area means nothing but what? Pi d square by 4. So pi, and diameter is becoming what? Half. So pi into d by 2 whole square divided by what? So here pi d square by, here 1 4, here 1 4, so into 1 by 4. So pi d square by 4 is nothing but what? It is, pi d square by 4 is nothing but what? Initial area. So this pi d square by 4 is first area A into 1 by 4. So A2 is equal to A by 4. So now we want R2 value. So let us calculate R2. R2 by R1 I am taking. So R2 means rho 2 L2 by A2, and R1 means rho 1 L1 by A1. Okay. So now I want R2 value. So what is a rho 2 value? Rho 2 value is, so rho 1 initially rho, again rho 2 is also rho, because the same material dimensions are changed. Material is not changed. So here also rho, here also rho. So rho 2 is rho, rho 1 is also rho. So both get cancelled. Then what will be getting? L2 by A2 divided by L1 by A1. This A1 will come into the numerator, then we'll be getting R2 by R1 is equal to L2A1 by L1A2. So from this what we'll get, please observe carefully. L2, length 2 is what? 2L. Length 2 is 2L, and A1 is nothing but what? A whole divided by L1. L1 is nothing but what? L. And area A2. A2 is how? A2 becomes how much? A by 4. A2 is A by 4. So here A by 4. This 4 comes into the numerator, and A get cancelled, length get cancelled. We will get what? 8. So what is the answer I got? R2 by R1 value I got as what? 8. Remember that value. R2 by R1 I got 8. So R2 is 8 times R1. That is 8 times R1 is nothing but what? R1 given is R. So what is the answer? 8 R ohms. So answer is what? D. Next, specific resistance of a material. Specific resistance of a material nothing but what? Rho. It depends upon the type of the material. It depends upon what type of the material. Here what options are given? Dimensions of the conductor. No, it does not depend on the dimensions of the conductor. Composition of a conductor of a material. That means type of the material. This is correct. It does not depend upon the resistance. So specific resistance depends upon composition of the conductor. Next, next question. With increase in temperature, the resistance of the pure metals. So as the temperature increases, in case of semiconductors, resistance is going to decrease. In case of the pure metals, as the temperature increases, resistance is going to increase. The answer is what? A. The material used mostly in making the standard resistance is manganese material is used. So answer is what? B. Now let us start with the inductor concept. A pure inductor dissipates energy, stores energy, doesn't dissipate energy, both B and C. We all know inductor stores energy in the magnetic field. The energy stored in the inductor, what is the formula? Half Li square. And inductor will not dissipate the energy. The correct answer is what? D. Both B and C. And the unit of inductance is what? Henry. So answer is what? A. Next, energy stored in the inductor in the form of magnetic field. Inductor stored the energy in the magnetic field. So what is the value of energy stored in the inductor? Half Li square. And inductor acts as dash to the DC. That means whenever DC power supply is given to the inductor, what is going to happen? We know voltage across inductor is L di by dt. So what power supply we are giving? DC power supply means constant voltage. So constant voltage will give us constant current. So this current becomes what? Constant. So V is equal to L differentiation of constant. So differentiation of constant is what? This value is going to become what? 0. So voltage becomes 0. Voltage becomes 0 means short circuit. So inductor acts as short circuit to DC. Next, consider the following statements. Carefully observe. Consider the following statements. An inductor acts like a short circuit to DC. This is correct. The current through an inductor cannot change instantaneously. We know inductor does not allow sudden changes in current. The property of the inductor is it does not allow sudden changes in current or changes in current. So this is also correct. current through an inductor can change instantaneously. No, current through the inductor cannot change instantaneously. uh, an inductor acts like open to DC. No, inductor acts as short circuit to DC. So options 1 and 2 are correct. 1 and 2 only. So the answer is what? B. Next, a network contains linear resistors, ideal voltage sources. If values of all the resistors are doubled, then voltage across each resistor is going to be remains the same. Next, an inductor is a two-terminal energy store. An inductor is a two-terminal energy storage device whose voltage is proportional to what? So inductor voltage formula L di by dt. So integral of the current passing through it, no, it is differentiation, right? So it's not integral. Integral of the flux across its, no. Derivative of the current passing through it, yes. So voltage across inductor V proportional to di by dt. So current differentiation, so derivative of the current passing through it, this is correct. Answer is what? C is correct. In an open device, current through it is. So here we are discussing about the open circuit. In open device, current through it. So open circuit means like this, as no closed circuit, current is going to be 0, and there will be some voltage will exist, but voltage we don't know, some voltage will be there. Let us say this is the open circuit, but it is connected to some power supply battery plus and minus V, and what will be the voltage across these two terminals? Voltage across these two terminals will be whatever the voltage is there, this will appear here. So voltage will be what? V, but current is going to be what? 0. So in open circuit, current is going to be 0. So in open device, current through it is 0 and voltage is unknown. Known and voltage is 0. 0 and voltage is 0. Unknown and voltage is unknown. So in open device, current through it is current. Here it is asking about current. Current is 0, but voltage is unknown. So answer is what? A. Next, some questions about the capacitor. The capacitance of a parallel plate capacitor is not affected by, that means capacitance of a parallel plate capacitor is not going to depend upon watt factor. We know capacitance value depends upon epsilon A by D. This is a formula. So dielectric material, capacitance value depends upon the cross sectional area of the plates and the distance between the two plates of the capacitor. So it depends upon the area of the plates, it depends upon the separation between the plates. Distance between the plates means separation between the plates. This is also called as separation between the plates, and it also depends upon the nature of the dielectric material. So it does not depend upon the thickness of the material. So here what it is asked, the capacitance of a parallel plate capacitor not affected by thickness of the plates, not affected by thickness of plates. The correct answer is what? B. Correct answer is B. How much energy stored by capacitor? 0. How much energy stored by capacitor? 0.05 microfarad. So C is equal to how much it is given? 0.05 microfarad, and with what voltage? 1000 volts is given. So V is equal to how much voltage is given? 1000 volts. So we need to calculate energy stored by the capacitor. C is equal to, energy stored by the capacitor, E is equal to, what is the formula? Half CV square. So that is, what is the formula? Energy half CV square. Half into capacitance is 0.05 into microfarad. So 10 power minus 6 farad into V square. Voltage is 1000. 1000 means 10 power 3. So 10 power 3 whole square. So this becomes 0.56. 10 power 3 whole square is this becomes 10 power plus 6, and this 10 power plus 6 to 10 power minus 6 cancel. What is the answer? 0.05 divided by what? 2. This is joules. So 0.05 by 2, that is 0.025 joules. So energy stored by the capacitor is how much? 0.025 joules. Answer is what? A. Let us go to the next question. Question number 3. 1 farad is equal to how much? Farad is the unit of what? Capacitance. So 1 farad is equal to how much? We know capacitance C is equal to Q divided by V. So Q is 1 coulomb and voltage units are nothing but what? 1 volt. So 1 coulomb per volt. 1 coulomb per volt. So answer is what? C. Next, let us go to the next question. Here capacitance C is equal to 5 microfarad, 5 into 10 to the power of minus 6 farad, and the voltage given is 100 volts. And what is the energy stored in the capacitor is asking. So energy stored in the capacitor, again energy stored in the capacitor is equal to half CV square. Half C is 5 into 10 power minus 6 and V square. So 100 volts given, 100 volts is nothing but what? 10 power 2. V square means 10 to the power of 4. So this is equal to half into 10 power 6, 10 power 4, 10 power minus 6. This is 10 power minus 2 into 5. So this is equal to, so 2.5 into 10 to the power of minus 2 joules. So 2.5 means 0.025 joules. The answer is what? A. Let us go to the next question. Just all these are basic questions only. 10 capacitors each of 10 microfarad. So how many capacitors are there? 10 capacitors. Number of capacitors are 10. Each capacitance value is 10 microfarad. They are connected in series. The combined capacitance is so now capacitors are connected in series and combined capacitance or total capacitance or equivalent capacitance we need to connect. So let us say if C1, C2, C3 are connected in parallel, then total capacitance we take it as C1 plus C2 plus C3. Resistors are connected in parallel, we say 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. Resistance and inductance formulas will be similar, but capacitance formula is opposite to the resistance formula. Like so when they are connected in parallel, this is the formula. When they are connected in series, 1 by Cp is equal to 1 by C1 plus 1 by C2 plus 1 by C3. But here one important thing is mentioned. Each capacitance value is same. Let us say n capacitors are connected. Each capacitance value is C. Then here you see n capacitors are connected and each capacitor capacitance value is C, and they are connected in parallel. Then they are connected in parallel means total capacitance value will be n into C. And when they are connected in series, then total capacitance value will be C by n. So what is the C value here? 10 microfarad. 10 microfarad by n means how many capacitors are there? How many capacitors? Again 10 capacitors. So 10. So what is the answer? 1 microfarad. So answer is what? 1 microfarad. Let us see the next question. In a capacitor, electric charge is stored in dielectric, metal plates, dielectric as well as metal plates, neither dielectric nor metal plates. So the charge is going to be stored in the dielectric. Here the question is about the practical current source. So practical current source, how we will represent? So this is the current source. So practical current source means it will be having some internal resistance. So internal resistance Rs to show total current will not be delivered to the load. We want to show some current will be divided into the internal resistance. To show the current division, we have to connect the things in parallel. So this is the representation of the practical current source. Current source is connected in parallel with the internal resistance. Let us see the options now. Option A, a resistance is in series with the ideal current source. It's not correct because here things are connected in parallel. A resistance is in parallel with the ideal current source. This is correct. A resistance is in parallel with the ideal voltage source. This is not correct. And the answer is what? B. So practical current source is in parallel with the internal resistance, but if you take practical voltage source, it will be in series with the internal resistance. It will be in series with the internal resistance. Next, again about the capacitor. Electrolytic capacitors are generally made up of aluminium. Answer is what? A. Next, we'll see some questions on the types of elements. Constant voltage source is, so he is asking about the voltage source. So this is the voltage source, and constant voltage source means it can deliver the energy. It can deliver the energy means it is a active element. It can deliver the energy in one direction, that means it is a unilateral element. So it is active and unilateral element. Constant voltage source is a active element and unilateral element. Next, the relation between voltage and current is same for two opposite directions of the current in case of dash network. So relationship between voltage and current is not changing with respect to the directions of the current. So that type of element we call as a bilateral element. So for different directions, the relationship between voltage and current is different, or impedance offered by the element is different, means that element we call as a unilateral element. But here the relationship between voltage and current is not changing, it is same. Therefore that type of element is known as what? Bilateral element. Example for bilateral element is nothing but what? Resistor. Next question. A circuit having neither energy source nor EMF is called. No energy source is present, no EMF source is present. So that type of element is known as what? Passive circuit. Answer is C. And next, again, the constant voltage source is a, just now we have already discussed, it is a active element and a unilateral element. Which of the following is a passive component? Here, semiconductor device is an active element, and vacuum tube is also an active element, and capacitor is a passive element. Even the capacitor can store the energy, but it cannot deliver the energy. It can deliver the energy, but it cannot deliver the energy continuously. So it's a passive element. Next, we will see some practice bits on Kirchhoff's laws, KCL and KVL. Very very important. So we can expect some questions from these Kirchhoff laws. Kirchhoff's laws are valid for Kirchhoff's laws are valid for linear element as well as non-linear element. So answer is D. Let us go to the next question. Kirchhoff laws are applicable to dash type of circuits. They are applicable to AC or DC, AC or DC, or both AC and DC, none of the both. They are applicable to both AC and DC. Answer is C. Kirchhoff laws are applicable to both AC circuits as well as DC circuits. Kirchhoff's current law is applicable only to. So asking about KCL. KCL we apply to node or junction. We apply the KCL at the node or junction. Answer is D. Let us see the next question. Dash law states that dash law states that the sum of currents entering into dash law states that the sum of currents entering into any node is equal to the sum of currents leaving from that node. So sum of currents entering into any node is equal to sum of current leaving that node. That is known as what? KCL, Kirchhoff's current law. So answer is what? C. Next, algebraic sum of voltages or voltage drop in any closed path of the network is traversed in a single direction is 0. Algebraic sum of voltages in a closed loop is 0. That is what? KVL. Next, Kirchhoff's law fails in case of, so in which case we can't apply the KCL. So we can't apply the KCL in case of distributed circuits. We can apply KCL in case of lumped circuit, but not in the distributed circuit. So we cannot apply KCL in the distributed circuit. So answer is D. Next, Kirchhoff's junction rule. Kirchhoff junction rule is nothing but what? KCL. Kirchhoff junction rule is KCL, and loop rule is nothing but what? KVL. Junction rule is KCL, loop rule is KVL for electric network are respectively based on. So we know KCL is based on conservation of charges. Conservation of charge. KVL is based on conservation of energy. So KCL is based on conservation of charge and KVL is based on conservation of energy. So that option we have to see. KCL is based on conservation of KCL is based on conservation of charge, KVL based on conservation of energy. So answer is D. And next we'll see the questions on the energy sources. Ideal current source has zero internal resistance. So ideal current source internal resistance is ideal current source has zero ideal voltage source has zero internal resistance. Ideal current source internal resistance is infinite. So internal resistance is infinite means 1 by resistance is nothing but what? Conductance. That is what? Zero internal conductance. Very careful. See, voltage source, if I take voltage source, this is the internal resistance, and if this voltage source total voltage has to go to the load means internal resistance must be 0. There should not be any voltage drop. So ideal voltage source internal resistance is 0. But similarly, this is the ideal current source. Next we will see ideal current source. This is the ideal current source. This total current should go to the load means there should not be any current division. That means this path resistance must be infinite. Therefore, ideal current source internal resistance is what? Infinite. So that no current will flow here. Total current will flow through the load. Ideal current source internal resistance is infinite. So internal resistance is infinite means this has to be 0. This has to be 0 means reciprocate both sides. 1 by Rs becomes what? 0. 1 by Rs nothing but what? Conductance. Internal conductance is 0. Next question. Internal resistance of ideal voltage source. Just now we have discussed internal resistance of ideal voltage source is what? 0. And next, if there are B branches and N nodes, then the number of equations will be. So this is standard question, branches minus nodes plus 1. So answer is what? D. Next, a closed path made by several branches of the network is known as loop. So closed path by several branches is known as what? Loop. The unit of MMF is, we know MMF is equal to number of turns N into current flowing through the each turn. So number of turns is nothing but just I am calling as turn, and current unit nothing but what? Ampere. So unit is ampere turn. So MMF unit is nothing but what? Ampere turn. Next, as the load supplied by the practical voltage source increases, its voltage its voltage remains constant, increases linearly, decreases linearly, and increases exponentially. So he is talking about the practical voltage source. Practical voltage source means it will be having some internal resistance. Let us say this is a source voltage and it is internal resistance Rs, and this is nothing but what? Load resistance, load RL. So here is nothing but what? Current is nothing but what? Is, and voltage across the load is nothing but what? Let us say terminal voltage Vt. So let us apply the KVL here. This is plus minus and this is plus minus. As the current is entering on the top terminal, this is plus and it is nothing but what? Minus. I am applying KVL in this direction. So minus 2 plus, it is nothing but what? Minus Vs, and here again I am coming across here plus Is into Rs plus Vt is equal to 0. So Vt is equal to Vs minus Is Rs. So its voltage remains constant as a load supplied by the practical voltage source increases. Load increases means current through the load is going to increase. Is is going to increase. So Is increases means this voltage drop is going to increase. Subtracting value increases means this total value is going to decrease. So output voltage is going to decrease. So answer is decreases linearly. Next, a practical current source is usually represented by, again practical current source means it will be having some internal resistance. So current source is going to be connected in parallel with the internal resistance. This is a practical current source. Current source is connected in parallel with the internal resistance. It is known as what? Practical current source. A resistance is in series with the ideal current source. No. A resistance is in parallel with the ideal current source. This is the correct answer. So answer is what? B. Let us see the next question. It is a previous question again. What does the following figure represents? So here diamond symbol is there means it is a dependent source. Dependent source or we can also call as control source. So arrow is represented. Arrow is represented means it is a current source. So it is a dependent current source. But dependent current source means current source current value depends upon what? It is given as KIX. Current source current value depending upon some other current. So it is current controlled current source, or we can also call as current dependent current source. So let us see the option. Current controlled voltage source. No. Arrow is there. Arrow is there means it is a current source. Voltage controlled current source. But it is not voltage controlled current source. Current source current value depending upon the current. So voltage controlled current source, it's not correct. Current controlled current source, it is correct. Voltage controlled voltage source, no. So answer is C. Next, let us see. An ideal constant voltage source is connected in series with the ideal current source. Considered together, the combination will be A. So here ideal voltage source is connected in series with the ideal current source. Actually practically we don't connect like this. This ideal current source try to maintain constant current in the circuit. Ideal voltage source will try to maintain fixed voltage in the circuit. But as it is a series connection, this circuit is going to behave like a constant current source, and voltage source will adjust its voltage accordingly based on the current given by the current source. So the answer is constant current source. Next, Ohm's law questions we'll see now. Ohm's law is applicable to we cannot apply the Ohm's law to semiconductors, we cannot apply the Ohm's law to electrolytes, we cannot apply the Ohm's law to arc lamps. So answer is D. Next, the curve representing the Ohm's law. So Ohm's law is nothing but what? The relation between current and voltage is what? Linear, I proportional to V. So we will be having the linear relationship between voltage and current. It's going to be a linear curve. Next, the construction for the validity under the Ohm's law is, so under what validity, under what condition the Ohm's law is going to be constructed. So the basic condition for the Ohm's law to be followed is temperature must be constant. So the answer is A. A linear resistor is one which obeys the Ampere law or Lenz law or Ohm's law or Kirchhoff law. So Ohm's law. So linear resistor means the relation between current and voltage is going to be linear. So this relation is nothing but what? Ohm's law. Answer is what? C. Ohm's law gives the relation between what and what? Voltage, current, time, not correct. Power, current and resistance, not correct. We know Ohm's law gives the relation between what? Voltage, current and resistance. V is equals to IR or V is equal to RI. So resistance, time and current. Resistance, time and current, no, not time. Voltage, current and resistance. Next, validity of Ohm's law requires what? So voltage should remain constant, temperature should vary, current should be inversely proportional to voltage, or temperature must remain constant. So voltage should remain constant, no. Temperature should vary, temperature should not vary. Current should be inversely proportional to voltage, no. And temperature must remain constant. This is the Ohm's law condition. Next, about the Ohm's law question, one more question. Ohm's law is applicable to DC circuit only, AC circuit only. DC circuit as well as AC circuit, provided account is taken into the induced EMF resulting from self-inductance circuit and the distribution of the current in the cross section of the circuit. DC circuit as well as AC circuit, provided account is taken the induced EMF resulting from mutual inductance of the circuit and distribution of current in cross section of the circuit. See, Ohm's law is applicable for DC circuits also, and it is also applicable for AC circuits. But in case of AC circuits, so we have to consider some other factors also. See, DC circuit as well as AC circuit, provided account is taken induced EMF resulting from self-inductance as well as distribution of the current in the circuit. So current value in AC circuit, it depends upon the impedance also. So in case of impedance, we consider resistance as well as other factors like inductive reactance or capacitive reactance. So let us say if we take inductive reactance, it depends upon the self-inductance, but self-inductance will influence the impedance will influence the current. So most of the time we don't get mutual inductance in all the circuits, but self-inductance will come in the circuits. Therefore answer is C. So usually this mutual inductance is not that much regular in all the circuit. So mutual inductance is it will come in case of only coupled circuits or transformer circuits. So the answer is what? C. So these are the few practice questions and previous year questions, very important questions from basic concepts. In the next video we'll discuss about series connection, parallel connection of resistors, inductors and capacitors, and there some practice questions and previous year questions. Thank you. We'll meet in the next video.